Hi dear students, let's see this question that was from the topic of induced EMF or induced electric field rather. So basically in this question, it is given this in this region, the electric field is changing and it is coming out of, sorry, magnetic field is changing, not electric field. Magnetic field is changing and is coming out of the screen, okay, at a constant rate. Okay, now if you consider this wire, so from A to B in this direction, so it is said that the clockwise induced EMF, the value is epsilon naught. Okay, clockwise induced EMF value is epsilon naught given as per the data. Okay, also A and B are very close to each other. Okay, so if you want to see the scenario, basically this type of thing is happening. Okay, so basically these 2 points are very close to each other, right? And so we can almost consider them as a full circle. Okay, we can almost consider them as a full circle. Okay, so induced EMF like this. Okay, like the positive polarity will be downwards. Okay, I will not talk about polarity, but I'm saying that the EMF, as you move in this direction, so electric field will be induced in the clockwise sense in this scenario. Okay, because magnetic field was coming outside and its flux was increasing. Okay, so uh, according to the Lenz's law, electric field will be induced in the clockwise direction, because we must put our thumb inside. If the flux increases outside, then according to Lenz's law, you should put your thumb inside, and you can see that fingers will be curling in the clockwise direction. So this is the value of epsilon naught, right? And we can almost consider that A and B are overlapping because they are infinitesimally close to each other. Now we have to find the value of VB minus VA along path 1 and VA minus VB along path 2. So they have shown two paths. You can see these two dotted lines, dotted curves. So this is path 1 and this is path 2. We have to find the VB minus VA along path 1 and VA minus VB along path 2. Value of VB minus VA has been defined as negative of induced EMF. Okay, negative of induced EMF, right? Now, if you consider this whole section, see how my pen is moving. Okay, so consider this type of closed loop. Okay, basically, crescent, will not call it crescent, whatever it looks like, Pac-Man, if you have seen that kind of figure. So basically this loop. Okay, so there is no change of flux within this loop. Okay, so we can say that net EMF induced in this loop will be zero, right? Now if I go from A to B along the wire, that means from A to B along the wire, then E dot dl, okay, plus B to A, from B to A, from B to A along the path 1. Okay, along the path 1. Okay, again E dot dl. So this total should be 0. Okay, so from A to B along the wire and B to A along the path 1. So this total should be 0. Now this value has already been given to us as epsilon naught, right? This value has been given to us as epsilon naught. So we can say that this value will become minus epsilon naught. You can take this on the LHS side. Okay. Now, if you see this definition, VB minus VA has been defined as negative of A to B E dot ds, right? So this value we can write as I'm writing here. Okay, so I'm writing over here. So this value E dot dl B say A, okay, can be written as negative of A say B, right? E dot dl, right? And this value was, this has gone on the right side, this, so it had become minus epsilon naught, because if you remember this was epsilon naught, so this goes on the right side, becomes minus epsilon naught. Okay, so if you can see the we have to find the value of VB minus VA along path 1. VB minus VA along path 1 will be negative of E dot ds, and this value comes out to be minus epsilon naught, right? This value comes out to be minus epsilon naught, as you can see. Okay, now so option like this answer will be minus epsilon naught. If you choose path 2, okay, if you choose path 2, So there, so for that, net EMF induced will be zero. Okay, how we can say that net EMF induced will be zero? It is very very easy to see. Okay, if you consider this type of path, this, okay, so basically we can say that, or you can consider this type of path as well, only the dotted path as well. Okay, so inside the dotted path there is no flux change, A and B is almost overlapping. Okay, inside the this dotted path there is no flux change, A and B we can say is almost overlapping. So we can say that the net EMF induced inside this will be zero. Okay, so for the for this part, for the path 2 it will be 0, and for the path 1 it will be minus epsilon naught. Okay, so correct answer will be minus epsilon naught comma 0. I hope you were able to understand the solution of this question. That's it. Thank you.